We spoke about PubSub in the previous video as an introduction. So let's take a look at some of the common use cases of PubSub itself. While there are many more, use cases we spoke about from a business standpoint in the first video of this week, specific to PubSub being used in other scenarios, there are a lot of different ways in which at the technical level you can actually get to use this data. So for instance, you could use PubSub as a mechanism to get real-time information about what is happening in a specific machine. So let's say for instance you have a cluster of containers, cluster of virtual machines, and those machines have their own resource utilization, and those resource utilization talks about things like CPUs and network and memory. Then that data, which is basically real-time CPU utilization data, memory data, etc., can be published into like a PubSub, and from PubSub I could then decide to have my own workload balancing logic, right, which reads the data and says, this machine seems to be highly occupied, so let me actually route new workloads to this other machine, right? So behind the scenes, Google Cloud especially uses PubSub for a lot of its own internal cluster management purposes, exactly in the same manner. The other way in which PubSub is very, very useful, and that's true for messaging services in general, is to implement asynchronous workflows. So we saw this example of the e-commerce platform, right? It has this multiple handoff points, which could create this point-to-point dependency. If you didn't have message service, then that would result in tight coupling. But if you did have the messaging service like PubSub, you could have these different systems be completely independently executing their own workflows via the state being exchanged through PubSub. So then the PubSub system becomes like a state exchange, right, system. That's one way to look at it. The other way to look at it is each service by itself could be using the event store again, right? Could be using PubSub again as a way to store its own state, so that its own service can have multiple different workflow stages that it tracks and then executes. Like for instance, the packaging service could be having multiple different handoff points. Like for instance, the person who's receiving the incoming message could then say, I acknowledge the receipt of the message. I'm going to hand it off to the appropriate worker in the appropriate physical warehouse where that particular shoe is available, right? So then there is a handoff to that particular person, and then that person, once they get the message, they then acknowledge again, and then they go about looking for that particular shoe in some kind of a rack, and then once they find the shoe, they come back and say, look, I found it. Please send the dispatch person. The dispatch person will then pick up the message, firstly acknowledge it, and then come with a ready box which is available for that shoe, which is meant for that shoe. And then once they come in, then this person will then keep the shoe in the dispatch box and send it out, etc. So if you think about it, that's actually multiple stages of workflows within that packaging service. And even for that, right, the state that's required for triggering the next step in that sequence, in that workflow, could again come through the same event store, right? Could come in through the same message service, same PubSub. So that's a very effective way to actually implement large-scale workflows where each step follows the hot potato principle. You could also use PubSub as the mechanism for allowing multiple different consumers to just seamlessly operate with each other without having to worry about dependencies on the publisher. So that's the act of distributing data, right? So a common way to think about this is PubSub or message service in general becomes a data hub. So just like you could think of a transportation hub as a central point from where multiple different destinations can be serviced, and people desiring to go to multiple different destinations can come to that hub and take a bus and get a seat and move on. Likewise, a data hub is a central place from where multiple different consumers can get the data of their choice. So that way, the central hub becomes like a distribution point, right? Distribution center. The PubSub can be looked at in a very similar way as well. So it's one service to rule them all, so to speak. right? And finally, of course, streaming, right? Streaming is, of course, the primary use case with which we started this. Okay, so what are some salient characteristics of Google PubSub specific technology? So I'd like to caveat the next couple of slides by saying these are common characteristics, the characteristics which were designed for when Google PubSub itself was designed. But having said that, a lot of technologies in the cloud which are born native in the cloud, they changed rapidly. So they have new versions come in, new features, new capabilities. So always check on the latest version of the technology that you use and ensure that it continues to have the same characteristics or better, right? And has not regressed on some of the features that you might see being discussed. So one of the common pitfalls that you might face as a developer is when you search online for documentation and you don't use the original source documentation. Like for instance, in Google PubSub's case, if you don't go to Google Cloud's documentation, let's say you get the documentation from somewhere else, or somebody else has written a blog post or put it on Stack Overflow or whatever. It's quite likely that whatever they have written is dated, because the pace at which technologies change in the cloud is just so rapid that even before you know it, already a new version is out and some of the features have changed, some of the interfaces, syntax and all of that has changed. So with that caveat, I would like to talk about three different salient characteristics of Google PubSub in the next 3 slides, and for the most part they should remain irrespective of the versions that Google introduces for PubSub in the future. Alright, so the entire point of PubSub being designed the way it is scalability. Scalability both in terms of publishing as well as in terms of consumption. So that asynchronous many-to-many messaging service that PubSub is allows for infinite scale, like practically infinite scale in terms of the ability for you to go up in terms of big data, go up in terms of velocity, volumes, etc. So what makes something a scalable system? It is that when load increases, the performance does not just fall off a cliff, right, and becomes dramatically bad very quickly. No, instead you would want the system to automatically scale and catch up, right, and keep up to pace with the load that's increased. In fact, the architecture of PubSub is actually it's a completely PaaS. In fact, you can almost think of it as a SaaS service in the sense of you absolutely do not need to control any hardware at all. Right? PubSub automatically manages hardware. There is not even any configuration that you have to worry about from a physical infrastructure perspective in terms of performance. So that is automatically taken care of. You just keep publishing. That's it. You're done. Right? Keep consuming. So you just focus on the business logic. So that is a critical way in which Google has designed PubSub. It's a very interesting way to design it. PubSub actually has 2 different, internal components. The first is what's called as the data plane, and the second is what's called as the control plane. The data plane is the plane. Think of it as a 2-dimensional or 3-dimensional plane on which all the data processing happens, all the data movement happens. So the data plane is what is responsible for connecting the publisher to the subscriber through the subscription and the topic, right? So that is the data plane. And then there is the control plane, which, like the name suggests, is responsible for control of publishing, consumption, subscription, etc. Right? So it's the control plane which keeps track of where in the subscription is a particular subscriber in terms of consuming the messages and what message I need to give next. But the act of giving the message itself is actually in the data plane. So these are 2 different planes operating independently of each other. But they have obviously cross-cutting lines, right? So the servers that are there in the data plane, they are called as forwarders. The servers in the control plane are called as routers. So the routers are responsible for ensuring that the right message control, right message passing happens, but the actual message itself is actually forwarded by the forwarders. Information from the routers is only needed when the assigned forwarders are not accessible to the publishers, meaning the data plane can operate completely independently, but if for some reason the subscription is down or the subscriber is down and comes back up again, that's when they can come to the control plane and say, give me the latest status. Give me the last message that was consumed so that I can consume the next message. Right? So that allows you to independently scale the control plane and the data plane without having to affect each other. Okay, so the next characteristic that I want to talk about is availability. Google PubSub is a PaaS, almost like a SaaS, like I mentioned, and it guarantees that once the data is published and it's acknowledged, the service is up and the data is not lost at all. Right? Very, very high degrees of availability. Now, this is actually measured in terms of obviously the type of issues that occur, where does a failure occur, etc., etc. But the critical thing is, whenever there's a failure, can the PubSub react to it automatically so that you don't have to worry about data loss. So what kind of failures can occur? Because it's a PaaS service, first and foremost, the hardware and the backend server software can fail. And obviously, there could also be failures related to the load, related to the scale of the system. So let's go back to the so let's go back to the internal architecture. So the forwarder, which is basically the server that's responsible for forwarding the data in the data plane, right? It makes sure that any set of messages that are there, that are being published, is actually written to n machines in the cluster, right? And therefore, when the messages are getting written, as and when the messages are getting written, at least the majority, simple majority of those clusters. So there's a typo here. It's actually going to be. Yeah. So as and when there is at least one simple majority of the machines which have actually had the data acknowledged, then the forwarder returns back to the publisher saying that the messages have been persisted. Why simple majority? Because even if one of the machines fail, and the machine failure could be one of the machines that acknowledged it, or could be one of the machines that is yet to receive it, doesn't matter. At least you have the tolerance to that one machine failure. Now, what is N here? N really refers to like the number of machines in the cluster, and the machines could be as decided by Google, based on the scalability, based on the volumes, based on the velocity with which the data comes in. That's not under your control. Once a message is persisted, which means at least a simple majority is acknowledged, then the forwarder acknowledges that receipt back to the publisher. So that's how it guarantees at least some level of availability in the face of one or a couple of machine failures. Now, within the cluster, so sorry, when I say machines, it's actually clusters, right? Multiple different clusters. The clusters themselves have machines within them. Within each cluster, the message is actually written to multiple disks, and the disks are managed by their own controllers. So there are multiple independent disks to which the data is written. So let's say that's N. Then at least a simple majority has to be acknowledged, has to be written to, right, within each of those clusters. Now, which means that we're talking about at least a simple majority of disks in at least a simple majority of the clusters need to be written to before the message is actually deemed to be persisted or available for downstream consumers to consume. So that's when the publisher gets the acknowledgement. So as you can imagine, this is like a very, very available system, because it can tolerate multiple disk failures, multiple cluster failures, etc. Now, eventually the consistency comes to, rather eventually the data becomes consistently replicated to all of the disks and all of the clusters, but that's not guaranteed to happen immediately. Sometimes it happens immediately, sometimes it takes time. That's okay. At least a simple majority is done. That's how Google PubSub guarantees availability. Then finally, in terms of latency, how does it get the real-time latencies? So latency is actually a combination of multiple things, right? So first is, it's the time it takes for the system to acknowledge, PubSub to acknowledge the published message. And second is the time it takes for the message to get delivered to a particular subscription and to a particular subscriber. Now, the publisher to this PubSub actually has some bit of network latency, which is outside the control of PubSub anyway. Likewise, the subscriber subscribing for this, getting a message from the subscription actually has a bit of network latency. That's also outside the scope of what PubSub can control. but within the PubSub ecosystem, the load balancing mechanisms allow for the publisher to publish to the closest data center that Google Cloud owns. And this closest data center is determined based on geolocation. And after that, right, after the first closest location is written to, that majority clusters and majority of the disks, etc., that is actually spread across multiple regions, right? And each of those regions have their own data centers, obviously, have their own instances of PubSub that's running, and that they cater to their own geolocations. But then, as these clusters get written to, you get copies of the data across multiple different clusters over a period of time, and those clusters themselves are in different regions. So that even if a region goes down dramatically, like because of an earthquake or because of some natural disaster, the data is actually available in another region. But the latency is not compromised. Latency is actually taken care of by having closest region respond back to the publisher immediately. So the other scenario is the consumption related scenario. When a subscriber consumes from a subscription for the messages, it connects to the nearest server. Again, it's geolocation based. It's Google PubSub's responsibility to make sure that the data is actually synced up across these regions. And therefore, when the subscriber attaches to a specific region, it immediately gets the data that it requires. So it's fairly sophisticated in what it does. Alright, so with that we'll stop. That's the close on PubSub. In the next video, we'll start looking at what is the technology that Google uses for the streaming processing. So far we spoke about PubSub, which is an example of a persistent store software. Let's close this video on this note. Thanks.